help you excel. It's not just our name, it's our mission statement. So today I'm going to show you a very introductory tutorial for Microsoft Access. This is for people who have some experience in Excel and are trying to first venture into Microsoft Access. So first I'm just going to launch the application. And this is what you're going to see. If this is your first time opening it, you won't have this history of databases that you've worked on. To create a new database, you would just click here on blank database. And it's tempting to just click create right away. But if you do, it's going to save to your documents folder with this very generic name, which may not be what you want. So unlike an Excel file, you can't just start working on a database and then save it later. You save it at the time that you create it, where you want it. So I'm going to click the folder here. When it first opens, it's going to open this table designer interface that I just really don't like. So I just close that. So to create your first table, I'm going to go to create and then table design. Access is different from Excel in a number of ways, but one of those ways is that it forces you to make really structured data systems. So you define tables instead of sheets, and you can't just freeform enter data into a grid the way you would in Microsoft Excel. You create very precisely defined fields with data types that you enter data into. So I'm going to define my columns here for table 1, and this is going to be my customer table. Every table in Access or any other database system for that matter should have a primary key, and I'm just going to use an auto number, and I will show you what that does here in a little bit and further explain what a primary key does. So I'm giving my field a name, I'm telling it it's an auto number, and then I'm clicking this little button here to make it the primary key. And you can see it's the primary key because it has this little key here off to the left. So for my person table, I'm going to start with a couple of basic fields. Now you'll notice for each of these fields, there's a data type. So of course, first name makes sense. We'd want that to be short text. Last name is also text. Email address is text. But for birth date, I want that to be a date. All right, so there's my basic definitions. And now I'm going to save that table. And what I'm saving is the design of the table. So I'm going to save it, and I'm going to call this customer. And I'll talk a little bit more about naming convention here in just a moment. Now to enter data, we need to change our view from design view, which allows you to change the design of the table, to datasheet view, which allows you to enter data into the table. There's two ways you can do that. You can click here, this little drop down, to go to datasheet view, or I usually just right click the tab and go to datasheet view here. So now I can start actually entering data into here. So I'm going to enter some fake data here. Okay, so I've just entered my first row of data into the database. Now I mentioned these primary key, the ID is an auto number, and you may have noticed it automatically generated that number for me. So now if I type another row, now it just automatically increments to that next value. So what that's doing for you is it's uniquely identifying each row. So for example, let's say you had two customers named Mary Jane, and everything about these two customers is exactly the same, but they are legitimately two different customers. The database can still tell them apart. So you can create orders for this Mary Jane under customer 2 and orders for this Mary Jane under customer 3. So your primary key is just a unique way of identifying every row. And you actually want it to be arbitrary. For example, you wouldn't want it to be based on the email address, because what if then Mary Jane changed her email address and now it's the same as someone else's, or whatever. It gets to be really messy really fast when you do that. So typically you just want to do an auto number, which is completely arbitrary. The number 3 has no connection to Mary Jane except for inside of our database, which is actually what we want. Okay, so I've got 4 rows of data here. Great. Now let's talk about naming convention. I named this table customer singular, even though the table is storing customers plural. The reason for that is It's a long-standing convention in database design that your table names represent one row of data in that table. So this table, if I look at each individual row, that one single row is representing an individual customer, singular, and therefore that is what I named my table. And then you'll also notice my naming convention for my field names, my column headers here. First name, the F is lower, the N is capital. Last name, lower, capital. That's what's called camel case. If you're not familiar, that's a really common naming convention in programming and developing. You can use any naming convention that you'd like, but I highly recommend that you keep to a very consistent naming convention. So some other commonly used naming conventions is called Pascal case, in which case you would capitalize the first letter of each word instead of just the second and subsequent words. So that would be an example of camel case naming convention. This is also really common in database design where you do all caps and you separate your words with an underscore. What I would recommend staying away from is using spaces in your field names. And the reason for that won't become immediately apparent until you've been coding for a while, but trust me, it gets to be a real pain in the rear because every time you want to refer to this field in the code, if there's a space, you have to surround that field name with a square bracket. You can't just do first space name. You have to put that bracket around it. So to get around that, I recommend not having any spaces or special characters in your field names. So this is the naming convention that I like. But like I said, the important thing is that you pick a naming convention and you stick to it. Okay, so now we have a table to hold our customers. Great. I want to keep track of orders for customers. So to do that, I'm going to create a separate table for orders that's going to relate back to this customer table. So I'm going to click on Create again and go to Table Design. I'm always going to start with ID, auto number, primary key. That should just become reflex. You don't even think about it. That's just what you do. Okay, first I mentioned it needs to relate back to the customer table. So this is going to store that number from our customer table. So when this Mary Jane wants to place an order, we'll put customer ID 2 in there. If Paul Sassy wants to place an order, we'll put customer ID 4 in here, for example. So that's how those two tables are going to relate to each other. So I'm going to give these two fields different data types. So we've got our order date and then our order total. Going back to naming conventions, whenever I have a foreign key, that's the technical name for this. So this is going to be a value that refers to the primary key in another table. So this customer ID, like I said, if Mary Jane wants to place an order, we'll put number 2 in here. And that's going to refer back to the primary key in this table. But on our order table, this is what's called a foreign key. My naming convention for that is always the table name that the foreign key is referring to, and then underscore, and then the name of the primary key on that table. So customer is my table. The name of that primary key on the customer table is ID. So that's a naming convention that I stick to very strictly. So I know exactly when I look at my my database design, when I look at this table later and I don't remember, I know exactly, okay, this is a foreign key to the customer table and the primary key on that table is ID. I'm going to save this now, and this table now I'm going to call order because each row on this table is going to represent one single order. I'm going to open this. I'm going to enter some data. So let's say Bob Smith wants to place an order. So that's customer 1. Order date is today, and his total is $123.50. Okay, so I've just entered an order for Bob Smith for today's date. Couple things that I forgot to do. I want to make some of these fields required, and I don't want this to have a default. So down here is where you have additional parameters that you can set up for your different fields. So default right now is 0. I don't want that. And I also want to make this field required. So it's impossible to leave that field blank. Same with order date. I want to make that field required. And then order total, I am also going to make that required. and I am not going to have a default for that. So now if I try to enter an order and I leave any of these blank, it's going to yell at me. So let's do Paul Satsy this time. So customer 4. Now you'll notice this record is in what is called a dirty state right now, which means this record has not yet been saved or committed. Committed is the technical term in database land. So if you see this little pencil over here, that's how you know it's currently in a dirty state. So even though I've made order date and order total required, it's not yelling at me yet. But as soon as I try to commit that record, it's going to enforce that rule, and it won't let me commit the record until I've fulfilled all of the constraints. So there's a couple ways that you can commit a record. You can click the save button, which now it's going to tell me order date must have a value. Or if you just click on a different row, that will also attempt to commit that record. So now it's going to force me. I have to put in an order date, which is great. Now if I try to save, see, order total. It's going to make me put in a value for my order total now. So that is another area where Access is very different from Excel, is Access will allow you to very strictly define rules that have to be followed. Another example would be, because this is a data type, I cannot put invalid values in here, and that it's actually going to check as soon as I try to leave that field. So I type Bob, and if I just try to go to a different field, it's going to immediately tell me that's an invalid value. You can't do that. And you may be thinking, yeah, but you can do that in Excel, right? And you kind of can. So if I go to data validation and I set up a rule here and I say it has to be a date and it has to be greater than 1/1/1900, so basically any date. Then if I try to type anything that's not a date, it's going to yell at me. True, it will. However, Excel will let you do things like this. I can copy and paste, and then you're overwriting that data validation. So now where you wanted to have a date, you've got Bob, which is clearly not a date. Okay. Also, there's not really an easy way to make something required. For example, you really don't have a way to make that column required. So you're going to end up with somebody just forgot, or somebody's going to put in something like that, and Excel will allow that to go in there, even though that's clearly not a valid date. It's okay. So Access is going to prevent all of those things from happening when you design your database well. I cannot type an invalid date in here, and there's no way I can't copy and paste into it to overwrite it. And if I make it required, I absolutely have to fill that value in. And there's just really not a way to do that in Excel. So that's just one of many advantages of using a relational database like Access over using Excel when you want to have really tightly controlled, clean data with integrity. Now you're thinking, great, but I don't want to have to look and say, okay, I've got a table here with 3,000 orders. I don't want to have to keep looking over here to see, okay, who is customer 4 in order to see who those people are. You're absolutely right. And I'm going to show you using a view how you can avoid having to do that. But first, I'm going to enter in a little bit more data here. So now I have 3 orders for customer 4. So a view or a query is how you can view data from more than one table at the same time. So I'm going to go to create, and this time I'm going to go to query design. And there's different types of queries where you can update data in bulk, you can add new data in bulk. But for this, I want a select query, which is the default. And then I'm going to drag those 2 tables in here, so they're both in my query builder here. And now I have to tell Microsoft Access how these 2 tables relate. So when I put customer ID 4 in here, that relates to the ID number on the customer field. So to make that relationship, I'm just going to click and drag. And now I've told Access that customer ID here belongs to ID over here. So now I want to see all of my customer details. And there's a couple ways that you can drag fields down into our query. You can just double click. You can click and drag. You can also select multiples. And then you can click and drag those down here as well. And then I also want my order information. And there we go. So now when I execute this query, we're going to see these 4 columns come from my customer table. These 2 columns come from my order table, and I'm going to see those side by side. So now here's my 4 columns from my customer table, and then my details from my order table. So I can see those all side by side. Now, my naming convention, again, you can use your own naming convention. I just highly recommend you stick to one, is that for select queries, I do V underscore and then whatever name makes sense to me. So I'm going to call this customer order. And again, in my object names, I also highly recommend avoiding spaces. So for queries and table names, to separate words, I usually do underscore. Now, with these views or queries, you can do a lot of things. So for example, if I wanted to sort by first name or last name and then first name, I can do that. And the sort order is going to be left to right. So whatever column is clear off to the left, that'll sort first. And then secondarily, it'll sort by first name. Now, you can also do other things. Like, for example, you could say where their birth date is less than now minus 365.25 times 21. So if I wanted to only show people who's currently older than 21, then I can filter that way. And then it'll only show customers who are currently older than 21 because I entered in Kayleen as being birthday of today. So she is very young indeed. So with your views, you can do a lot of different filtering. You can rearrange your data. You can resort your data. Now, when I built that query, I had to define this relationship. The way I've done it right now, every time I create a new query with those 2 tables, I would have to redefine that relationship over and over again. There's another way that you can permanently define relationships in Microsoft Access, and you do that through the Database Tools tab, and then you go to Relationships. Similar to building a query, I'm just going to drag my 2 tables in here. And again, similar to building a query, I'm going to click and drag to tell Access how these 2 tables are related. But this time now, I'm going to get some additional options here. So first, I'm going to check this for now, and I'll explain it in just a moment. But I want to enforce referential integrity. What that's going to do is it's going to make sure that if I say customer 6 on the order table, that there really is a customer 6 in the customer table. And now you'll see it recognizes this is a one-to-many relationship. So that's the infinite sign. So every ID number in this table is going to appear exactly once because it's the primary key. It has to appear exactly once. But there's a possibility in this table that that same ID could appear an infinite number of times. So that's called a one-to-many relationship. So now if I were to start a new query and I needed the customer and the order tables, it automatically draws that join for me, and Access even recognizes that that is a one-to-many relationship. So now if I wanted a different view where, let's say I want the order date first, and then I just want the email address, and I just want the total, and I want to sort by order date and then email address, then I can do that. So now I have a second view. Call this version 2. Since I turned on referential integrity, it's going to protect me from invalid data entry. So let's open these 2 tables again. Right now I have customers 1, 2, 3, 4, and 5. If I try to take an order for customer 6, it will not let me do that. As soon as I try to commit that record, it is going to block me from being able to do that. So when I hit commit, I cannot do that. There is not a related record in the customer table. Okay, if I change this to a value that is valid in my customer table, it will now let me save that just fine. The other thing that it will do, let's say you've decided, oops, this Mary Jane was a mistake. We actually don't need Mary Jane twice. I'm going to delete Mary Jane. Okay, it let me do that because Mary Jane had no orders, but I'm going to enter in an order for this other Mary Jane. So now Mary Jane with ID of 3 has an order. So if I try to delete Mary Jane now, it won't let me do that, because if I did that, it would create what's called an orphan. So I would have a record here saying that customer number 3 placed an order, but I have no corresponding customer 3 on my order table. The other thing that creating the relationship did for us is Access will automatically create subtables for us. So here, if I look to the left, this little plus is now here. And if I expand this, this is showing me information now from the order table. So these are my order dates and order totals that relate only to this specific customer. So if I go to the order table and I look at orders for customer 4, you'll see I have 2, 3, 4, and 7. 2, 3, 4, and 7, and then those various dates. So now if I want to create a new order for me, for Paul Sassy, I can just go in here and enter my new order. And now that new order has been created. So now if I go to the orders table and refresh, we do have to refresh. There's that new order, number 9. It's related to Paul Sassy. So even without building any forms, you have a fairly functional database here now that you could use to capture orders. So you find your customer, you go in here, you enter in your order date and your order total, and there you go. You've created an order for Mary Jane. Now, I recognize that you probably want to keep track of what items Mary Jane ordered on this order. And to do that, you would create additional tables, which gets beyond what I intend to do for this video. But in future videos, I'll build this out further and we'll create an item table where we will have a list of items that we sell. And then I'll also create an order detail table that will build a list of what items are on each order. So we'll create a second table that'll refer to this order table, and then it'll have a row for every item that that customer ordered on that particular order. But that's where I'll leave it for today. We'll keep it simple today just to get you a very basic primer. I hope you enjoyed this video. Stay tuned for more like this.